So, like I mentioned in the warm-up, today's work is almost exactly like what we were talking about last week. The only difference is now we're dealing with an equal sign. So we're still going to simplify it in the same exact way that we would, except it's going to look just slightly different. So let's take a look here. We have a toolkit of things that we can use to solve equations, right? We can distribute, we can fraction bust, we can use inverse operations. Now what we're going to add to that toolkit, that ever-filling toolkit, is using a square root to solve for a missing variable. Leslie?
When are we going to work on note sheet number 7?
Great question. We'll go over note sheet 7 together as soon as we get through this one, note sheet 8. Thank you. Yeah. We'll talk about note sheet 7. If you got it done, great. If not, again, it's in your notebook, so it's not a graded assignment. I just wanted to see if you were able to get through that all on your own. But we'll check that here in just a second. So, for example, it's kind of hard to see, but this little gray box here says example 1. We've got x squared is equal to 36. Now, a lot of us, just by looking at this, will be able to tell what x is going to be equal to, right? Because we can fill in the blank in our head. Well, we take a number and we square it and we get 36. That must mean my x is what? 6, right? You're exactly right. But here's what we're actually doing. We are taking the square root of both sides. Remember, what we do to one side, we always have to do to the other. An equation is like a scale. It needs to be balanced on both sides for it to work. So if we have this equation, x squared equals 36, remember, our goal here when solving any type of equation is to get the variable all by itself. Now, is x all by itself right now? No, it's got that exponent of 2 on top. Just like in the previous unit, if it was 2x equals 36, we could recognize that x is not all by itself. And when x is not by itself, for example, just so we can relate back to what we were talking about in the last lesson, if we had 2x equals 36, right? What are we currently doing to x here? We're multiplying. So in order to get x by itself, we have to do the inverse of multiplying, which would be what? Dividing, right? We divided both sides by 2. Those crossed out. And we got x is equal to 18. That's how we would solve our equations before. So we're still going to do the same type of thing. We need to do the inverse of whatever we're doing here. What we're doing right now is we're squaring x, right? We're raising x to the power of 2. And remember, we talked about at the beginning of the unit, at the beginning of this unit, the inverse of squaring something is taking the square root of something. So if we want to get x squared by itself, we have to take the square root. Okay, we have to take the square root of both sides. Same type of operation as when we were multiplying both sides by 2 or dividing both sides by 2. Or subtracting 2 from both sides, anything like that. Same concept, right? Then we just have to simplify, right? If we wanted to expand out, and let's actually do this. If we wanted to expand out the square root of x squared, we could say that it looks like this. The square root of x times x. Right? If we did a little makeshift factor tree for x squared, well, the only two things that can multiply by each other to give us x squared is x times x. Do we see a identical pair here that we can pull out? Right here in this square root? Do we see an identical pair of terms at all, folks? Yes. Yeah, we see a pair of x's. It's a little bit different now that it's a variable instead of a number, but it's going to work the same way. We group up that identical pair and bring it out in front. That gives us this little x all alone. Now here's an interesting part of this. We don't need a plus or minus sign in front of x because x is a variable. It can be anything, right? X could be negative 6, x could be positive 6. It could be anything. So we don't need to specify that it's a plus or minus type of number. On the right-hand side, though, we do. If we simplify the right-hand side, we get the square root of 6 times 6. Again, do we have an identical pair here we can pull out? Yeah, we sure do. It's that pair of 6s right there. Bring that out in front, and that gives us that plus or minus 6 on the right. Yes, sure. So our answer here is x equals plus or minus 6. And this makes sense, right? Because what's negative 6 times negative 6? Positive 36, right? So when we take the square root of both sides, we know that our answer is going to be 6, but we don't know if it's 2 positive 6s or 2 negative 6s. Because in both instances, they multiplied by each other to get the same exact perfect square of positive 36. Give me a thumbs up if you're with me so far. This is making a little bit of sense. You can see how this connects to what we were talking about last week. Good. I'll leave this here for a couple moments before we move forward. All right, let's move on. Let's move on down here. Actually, I want to add something. Off to the left-hand side, I want you to point an arrow, and I want you to write rational. So that's how we're going to solve square root equations with a rational square root, meaning that everything comes out of the square root and we don't have a square root in our answer. Remember, a rational number is just a number that we can represent as a fraction. That's the key, a fraction of two numbers. So let's go down to example 2. Let's deal with an irrational number now, an irrational number. Now we're going to deal with an irrational number, which means we're not going to get a nice even answer like 6 or 8 or 10. We're going to have plus or minus something, root something as our answer. So if we have y squared equals 80, we again can ask ourselves, well, what am I doing to my variable? What's the answer? What are we doing to y right here? Anybody want to take a guess? What are we doing to y right here? Yes, we're squaring it, right? The opposite or the inverse of squaring something, whether it's a number or a variable, is to take the square root. To take the square root. But again, we can't just do it to both sides, we can't just do it to one side. We have to take the square root of both sides. That is non-negotiable. We have to take the square root on both sides. Is 80 a perfect square? No, definitely not. So we're going to have to do a little factor tree here for 80. I'm going to do it off to the side. Who can help me out? What two numbers multiply to get 80, Kenny?
8 and 10.
8 and 10.
And
Perfect.
you can break it down and you do 4 and 4.
4 and 2.
Don't you mean 4 and 2? Oh, my bad, 4.
That's all right.
And then 5 and 2. And then break that down in 2 and 2.
Perfect.
And you can break the 2's into 1 and 1.
So we're not going to do that. We don't need to break the 2's anymore, but
plus
perfect.
Sign in between them, so 1 plus 1 equals 2.
So good. That's great thinking, right? You would think, okay, I can split my 2's up further, right? But remember, we're not talking about addition here at all. We're only talking about multiplying. Thank you, Kenny. So we got 2, 2, 2, 2, and 5.
That's a lot of 2's.
Those are our factors, right?
But can't you combine them together? So now you got 2 pairs of 2.
Well, let's take a look. If we rewrite our square root, we could say it's 2 times 2 times 2 times 2 times 5 Now, do we have any identical pairs we can pull out
Yeah,
here?
you got two of them.
We got 2 pairs of 2s, right? There's 1, there's 2. We're going to bring them both out in front.
That's gotta equal 4
That's right. We're going to multiply them to get 4 in the front.
times 5. So that's 20 in the inside.
So, hold on now. Let's think about this, right?
Oh,
Can't
my
go
bad,
too
man.
quick,
You said
'cause-
5 on the inside.
That's right. We pulled the 2's out, which means the only thing left under that square root umbrella is that 5 right there. So we bring the 2's out in front and multiply them, right? We're always multiplying with this work. That gives us a 4 in the front. And the 5 is left over inside the square root. So think about it. This would be the exact same answer as if I just had given you the square root of 80 and told you to simplify, right? You would have done a factor tree. You would have lined up all the factors, identified the matching pairs and pulled them out, and wrote our answer just like this. It's the exact same thing we were just doing. The only difference here is the specificity of having to take the square root of both sides and interacting with this like an equation. Okay, and we could take this a step further and do some things where we've got to subtract from both sides or distribute, but we're not going to go crazy. We're going to keep it nice and simple. So, here's 4 square root equations that I want you guys to try on your own. I'm going to come by and take a look at how you guys are doing with this. We'll review it, and then we'll jump back to note sheet 7 and review that. So give these a try. Take the square root of both sides, simplify as much as you can, and don't forget your plus or minus sign. We're going to take like 2 minutes to do this, and then we'll jump back in.
I used to that.
Sure. Yeah.
I got chased by the season. That's where they knew you're a big food. They were gonna be fools.
So with this one, because these are perfect squares, we take those 12s out, and we don't have a square root.
That brings up a good point. Let's go ahead and talk about this real quick. So, I probably should have modeled one of these for us. That's my bad. So let's take a look at number 1. We got x squared equals 144. Again, what's our goal here? Anytime we're solving an equation, what's our goal? Who can tell me for a rich ticket what our goal is here? Azalea, what's our goal?
To get x by itself.
To get x all by itself. Exactly. To do that, we need to do the inverse of what we're doing to x right now. What are we doing to x right now in this problem? We're squaring it. The inverse of squaring a number is going to be what, everybody? Or Azalea, what is it going to be? Taking the square root. Exactly.
You need help with anything. Because here right now.
Oh, yeah. Of course. I have a TA for you. Thank you, Paige. So, we got x squared. All we need to do is take the square root of both sides. We're going to hit the left side with a square root. And we're going to hit the right side with a square root just like that. Now, if we're going to simplify both sides, it'll be x times x on the left, 12 times 12 on the right. Take a look at how I'm doing this so that you know when we get to our worksheet what you're going to do. We're going to bring those x's out. We're going to bring those 12s out. And we're left with x equals 12. Now, is my answer just going to be 12?
Yes.
No, it's going to be plus or minus 12. We have to include the possibility that we have a negative 12 times a negative 12. Last week, with what we started out on, the questions would have looked like this. Let me show you. Last week, our questions looked like this. Simplify the square root of 144. And we would have, of course, know that it's plus or minus 12. The only difference here is this addition of our variable. I'm really, really hoping you guys see that. It's the exact same thing we talked about last week. Right? Number 2 is another perfect square. You can try that one on your own. Just follow exactly what we did in number 1, and you'll be good to go. But let's look at number 3 was from the warm-up, right? 120? Yeah, we did 12 times 10. So you can look to the warm-up if you need help on number 3, but number 4, again, we're going to take the square root of both sides. Is 48 a perfect square, everybody?
Yes.
48?
No.
No, definitely not. 48 is what? 4 times 12? You can do 8 times 6 too. You'll get the same factors. 2 times 2. 12 is 3 times 4. And 4 is just 2 times 2. So we got 2, 2, 2, 2, and a 3. So our W clears out. We get rid of that exponent because the exponent and our square root sign cancel each other out. And we're left with the square root of 2 times 2 times 2 times 2 times 3. Any identical pairs we can pull out here? Yeah, we got 2 pairs of 2s. We're going to bring those both out and do what with them in front? We're going to multiply them. Thank you, Alexa. We're going to multiply them to get 4 root. What's left over inside the square root here? Just the 3, right? Hit it with a plus or minus in the front. And there is our answer. W is equal to plus or minus 4 root 3. Again, same exact process as last week. Factor tree. Group up those identical pairs and bring them out. Multiply them in front if you need to. And whatever's left behind stays inside the square root. Any questions I can answer about how we're getting this done? Show of thumbs, how do we feel about getting this done potentially on our own here in a little bit? Thumbs up if we're feeling good, confident, nice. Thumbs sideways if maybe we need to take a look at a little more examples. Thumbs down if the donut completely knocked you out and now you don't have any motivation to do what we're doing right now.
All right, what?
Okay, good. I see no thumbs down. That's perfect.